Now we're going to think about the graph of sine and cosines. Well, you already know the basic ones. Y equals to sine x. That's, you have 360, 180, 90, and then midpoint of these two is 270. And the graph starts from 0, goes to up to 1, down to 0, goes down to -1, and comes back to 0. So that's the graph. And really, it repeats, right? So the 90 plus 360, that's 450 degrees. It's like this. So what we know is that this function has a period of 360 degrees. Now this is twice of 180 degrees, and since 180 degrees in radians is pi, it's 2 times pi. Okay, so period is 2 pi. And then this height of the function, that's called the amplitude. And so from the midpoint to the highest point, that's called the amplitude. Okay, so here we call this the amplitude. And the amplitude of this function is just 1. Alright, and then the midpoint of the graph is 0. We call that the vertical shift. It's not shifted at all, so the vertical shift is 0. But we're going to see that you could have some vertical shifts that make everything go up by a certain number or go down by a certain number. Alright, knowing this, the goal of this lesson is to be able to draw a graph like y equals to 2 times sine of 3x plus pi over 6 and then plus 3. Okay, already this looks very bad. So let me use some calculator to see what that gives us. Okay, so here's a website. It has a Desmos website has this graphing calculator. I already tried something. Okay, so let's try this. You have sine of x. This is this red one. Same thing as before, except this is given in radians. So as I noted before, 2 pi is 1 full period. So from 0 to 2 pi, twice of pi is like 6.28. So that's where this ends. Now what happens if I do 2 times sine 3x? I said that plus pi over 6. What did I write? Plus 3? Okay, so if you have plus 3. So plus 3 immediately made everything go up. And then this 3 makes things get squashed. 2 makes it taller. And then plus pi over 6, it kind of shifts around. Okay. So it's very confusing, but at least there's a bright side, which is that if you take this form, which we call the sinusoidal curve, anything that looks like a wave, that's called the sinusoidal curve. Whatever you multiply in front and multiply in front of x plus something and then plus something, this is the generic format you're going to see, and these formats always will produce another kind of sinusoidal curve. And knowing that will help us a lot in being able to draw the graph of these functions. So let's try to tackle this problem one by one. First, what I want to do is to try to tackle the one that has some numbers in front. So what if you had like 3 times sine x? What's the graph? Well, what you need to know is that the sine graph, if you just said y equals to sine of x, that has the period of 360 degrees and 270 degrees here. And it goes from 0 to 1, 0, and then -1 and then 0. Okay, so 0, 1, 0, -1, and 0. Now, what if you had a 3 in front? Well, 3 times sine of 90 degrees would be, sine 90 is 1, and then you multiply by 3, you're going to get 3 times this. So it's going to be 2 and then 3 here. So suddenly it's going to go way up there. So 0 times 3 is 0, so it goes all the way here. And it comes back down to 0 again, because 0 times 3 is still 0. And then 0 times negative 1 is like negative 3. So here, let's call this negative 3. And then it comes back up. So what we see is that the number in front of the graph actually gives you the amplitude. Before, the amplitude was 1 when you didn't have anything. But when you put the 3, now 1 got amplified to 3. So A is the amplitude. Alright, next thing you need to know is what happens if you did like sine of x plus 2. Alright, let's think about that. Again, we go to the previous graph. 360, 180, 90, 270. The more you practice drawing this, the better you're going to get, and you'll be more comfortable with the sine graph. Okay, so here's 1, here's negative 1, and 0. Now this time you're adding 2 to all the values of sine. So what it was 1 now becomes 3. What was 0 now becomes 0 plus 2 and be 2. What was 0 will be 2. And then what was negative 1? Negative 1 plus 2 is positive 1. And then 0 again. So you get a graph that looks like this. So what we learned is that if you have sine x and you multiply by a and add a b, a will be the amplitude, which is the distance between the center to the highest point, or it's the, in this case the amplitude is still 1 because from the center of this graph is right here, and then the highest point is 1 above the center. Okay, so since sine of x can be thought as 1 times sine x, amplitude is 1 in this case, and b shifts the entire thing up or down depending on the value that, whether if you add it's going to go up, if you subtract it's going to go down, right? So b is what we call the vertical shift. Okay, and actually that's the easy part. Now let's tackle the harder part. How do you do y equals the sine of, say, 3x minus pi over 3, something like this? If you have a graph like this, what do you do? Well, there are many ways to tackle this problem, but I think, and I'm confident that I can teach you the easiest method to figure this out. And the easiest method is the following. See, the regular sine function has these very important values at 0, 90, 180, 270, 360. Okay? And because sine becomes 0 and then 1 and then 0 and then negative 1 and 0. So you get something like this. Okay? And I'm borrowing this idea from artists. See, people who draw portraits or caricatures, they use the most distinguishing parts of a person's face to have a good resemblance of that person, right? So if you're trying to draw the graph of sine, what you need to know is the most distinguishing parts of the sine function. And the sine function has these distinguishing part values at 0, 0, 90, and then you get 1, 180 you get 0, and 270 at negative 1, and at 360 you get 0. Now let me make another adjustments here, and another adjustment is now you have to know how to draw this using radians, because most of the problems that you're going to get in this part is they ask you to draw in terms of radians. So we're going to draw in radians, and it's not too bad. You start from 2 pi because 360 is 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. And you need the midpoint between pi and 2 pi. That's just the average. You add the pi and 2 pi, that's 3 pi, right? And then you divide by 2. That's how you get the average of two numbers, right? Add them together and divide by 2. So these are the 90, 180, 270, 360. And at those points, including 0, is 0, 1, 0, negative 1, and 0. Okay. Alright, I feel like I spent much more time explaining the original graph of the sine, and I still haven't told you how to draw this one. Well, here is the method that I like to use. The method I like to use is just set 3x minus pi over 3 equal to these important values. Those are the distinguishing values of the sine. So what I'm going to do is, if I want the graph of this new thing, I better know when this is equal to 0, when this is equal to pi over 2, when this is equal to pi, when this is equal to 3 pi over 2, and when this is equal to 2 pi. Because when this value is equal to these, then so for example, let's do this first. Adding pi over 3, that's 3x equals to pi over 3, and then divide by 3, that gives you x equals to pi over 9. So in other words, when you plug in pi over 9 here, then the entire thing becomes 0, and because sine of 0 is 0, I get a 0 for that. So we know that for this graph, at pi over 9, let's just call this pi over 9, and this point is where the sine will become 0. And that's actually very important because you already know something about this graph. Now you just have to know the next stop, when it hits 1, when it hits 0 again, when it's negative 1, when it's 0. And once you have that, then you have the full graph, okay? So that's exactly what we're going after. Alright, so let's try the next one. If 3x minus pi over 3 is pi over 2, you can say 3x is equal to pi over 2 plus pi over 3. Which if you make common denominators, multiply 3 top and bottom, that's 3 pi over 6, multiply 2 top and bottom, that's 2 pi over 6, add them together, that's 5 pi over 6, right? And then finally, when you divide by 3, you get x equals to 5 pi over 18. Okay, same thing here, 3x equals to pi plus pi over 3, and it takes a while, but it's not that bad. X equals to 4 pi over 9. And this one. And still another way to get this is, you can even skip this and just go for 2 pi, and then later get this by knowing that it's the midpoint of the two. So let me show you that trick too. So 3x is 2 pi plus pi over 3. What I'm doing is, I'm trying to solve this equation, right? 3x minus pi over 3 equals to 2 pi. Add pi over 3 both sides, this is what you get. And if you solve for x, you're going to get 7 pi over 9. And to get the one that corresponds to 3 pi over 2, you just simply take the 4 pi over 9 and 7 pi over 9, and you add them together and divide by 2. That's how you take the average. So you get 11 pi over 9 divided by 2, that's 11 pi over 18. Okay, so you got these points. Now what do? Well, your work is almost done. It's almost done. So what you want to do is simply take a point, and if you're not sure of exactly where to put, just imagine that pi is 3, right? Pi is 3.14, just pi is 3. So 3 divided by 9, that's like 1/3, right? So let's just say this is 1, and then pi over 9 will be 1/3 of that. So let's call this as pi over 9. And then the next step is 5 pi over 9, 5 pi over 18. 5 times 3, is 15 divided by 18, so it's about 5/6. 5/6 is pretty close to 1, so I'm just going to call this as 5 pi over 18. And the next stop is 4 pi over 9. That's, let's see, 3 times 4, 12 over 9, that's 4 over 3. So it's somewhere here. And once you know exactly where that, if you know like first two, then you know the next one because it says evenly spaced. The original ones are evenly spaced, so here, 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 another evenly spaced one, another evenly spaced one. You just have to know those 5 points. Knowing the 5 points will tell you exactly where you should be drawing. So 5 pi over 18 is the next one. The next one is 4 pi over 9. And then the next one is 11 pi over 18. And then lastly, it's 7 pi over 9. Okay. And then you have to remember that the sine graph is 0, 1, 0, -1, 0. And that's the graph of one full period. And of course, this repeats itself, so you can draw more if you need. And you can even figure out the stop before it just by figuring out these lengths. Now, there is, however, another thing that you should be aware of, which is what is the actual period? Period is this ending point minus initial point, right? So you can do 7 pi over 9 minus pi over 9, which is 6 pi over 9. And you can simplify top and bottom by dividing by 3, so it's 2 pi over 3. That is the period. Okay. Now, here, let me do another example, and if this was too much work, I can even make it simpler. So let's say we have this time y equals to sine of 2x plus pi over 6. Let's try this. Oh, okay. Again, I'm not even going to talk about the sine graph. You just think about when this is equal to 0, and then when it's equal to pi over 2, when it's equal to pi, when it's equal to 3 pi over 2, and then when it's equal to 2 pi. And furthermore, we can skip these and just figure out the initial and the final and figure out the other points just by taking midpoints, because so I'll just do it and you'll see what I mean. Okay, so 2x equals to negative pi over 6 divided by 2, and then you get x equals to negative pi over 12. Okay. And then here, if I solve 2x plus pi over 6 equals to 2 pi, then I get 2x equals to 2 pi minus pi over 6. Well, I need a common denominator, so I make this as 12 pi over 6 minus pi over 6, which is 11 pi over 12. Okay. Now, then I can just start taking midpoints to get the middle one, and then take midpoints and so on and so on. So, how do you get the midpoints? Add the 2. That's negative pi, and that's 11 pi. Adding the 2 gives you 10 pi, right? 10 pi over 12. And then you have to divide this by 2. That's the one that corresponds to pi. Well, reduce this. It's 5 over 6, and then 6 times 2 is 12, so it's 5 pi over 12. Again, if you want the midpoint, add the 2. That's 4 pi over 12. And then you divide by 2. 4 over 12 is 1/3. Pi over 3 divided by 2 is pi over 6. Add these two. 5 plus 11, that's 16. And then divide by 2. So it's 8 over 3. No, actually, 4 times 4. 4 times 3. So this is 4 pi over 3 divided by 2. So that's 4 pi over 6. We can also reduce and say this is 2 pi over 3. Okay, so we're almost there. Pi is 3, so it's like 3 over 12 is like 1/4. So if this is -1, it's like 1/4 of it. So right here, that's where the 0 begins. And then here, this is 3 times 11 over 12. Just estimate pi as 3. Let's see what happens. This is like 4. 11 divided by 4, that's about 0. I can't do this. 2.5, but another 1/4. So 2.75 is what you get. Okay, so about 2.75. So here's +1. If this is 1, that would be +1, +2, +3, and 2.7. Somewhere here will be my 2 pi over 3, and this would, no, not 2 pi over 3, it's 11 pi over 12, and then we just put all the other points. So this is -pi over 12, and then midpoint is somewhere here, which is 5 pi over 12, and then you have another midpoint here, which is pi over 6. Another midpoint between there is 2 pi over 3. Okay, so we have those 5 points ready. Now just connect them by 0, 1, 0, -1, 0, and now you have the graph. Okay, now let's also figure out the period, which is the difference of these two, 11 pi over 12 minus -pi over 12, which is 12 pi over 12, which is pi. So period is pi. This length here is pi. Another thing I should have mentioned in the previous question is the phase shift. It's about where the thing begins. The thing begins at -pi over 12, right? So the very first number is called the phase shift. So that's -pi over 12. Oh, right, it's called the phase shift. Okay, so the very first number is called the phase shift. Okay, now we can put everything together, amplitude and vertical shift and everything. So let me try the ultimate, and this time I'm going to try it with the cosine, right? So hardest one, and hopefully if you learn the tricks, this won't be that bad. Okay, so 3 times cosine, we're going to do 4x minus pi over 3 plus 1. Alright, how do you draw the graph of this? Okay, now since putting everything together is quite challenging, we're just going to do this much first. Okay, and then we're just going to shift everything up by 1, and that's our graph. Okay, so first set 4x minus pi over 3 equals to 0 and also equals to 2 pi, and we can take midpoints, right? And this one gives you 4x equals to pi over 3, and that gives you x equals to pi over 12. Okay, that's our phase shift. And then 4x minus pi over 3 is 2 pi. Add pi over 3 both sides. And this is 2 pi is what? It's 6 pi over 3. So I needed this to make common denominator, so that's 7 pi over 3. Okay, now to make this easy to take midpoints of, I'm going to write it in terms of over 12. So this is, after multiplying by 4, it's 28. 7 times 4 is 28 over 12. Okay, so what's the midpoint? The midpoint is, oh, sorry, I made a mistake here. Something didn't seem right. Okay, so if you divide by 4, then you get the x, right? So dividing by 4, you get 7 pi over 12. Okay, so now you didn't have to do this. I'm sorry. All right, so you have 7 pi over 12 as the end point. The beginning point, the phase shift is pi over 12. Now to get the midpoint and the midpoints of the midpoint, here's what we do. Add the 2, which is 8 pi over 12, and that's equal to 2 pi over 3, and then you divide by 2. 2 over 2 is 1, so it's pi over 3. That's the midpoint. Okay, that's also the same thing as 4 pi over 12. I'm writing it this way so I can easily calculate the midpoint. Add the 2, which is 5 pi over 12, and then divide by 2, so that's 5 pi over 24. Add these two, which is 11 pi over 12, and divide by 2. That's 11 pi over 24. Okay. So here is what we get. We get pi over 12 here, and then 7 pi over 12. What's that? That's 3 over 12 is 1/4. So it's little less than 2. So it's like this is 1/4. So if this is 1, it's a little less than 2. Alright, so let's just say it's somewhere here. We don't have to be exact, right? So we're going to put 7 pi over 12. If you are given a grid paper to draw this, you should just make pi as 3 and try to draw it there. Okay, and then you divide this into half, and then half, and half, and just write these values. This is 5 pi over 24, this is pi over 3, and this is 11 pi over 24. Okay, so it's almost done, but be careful. We were drawing only the sine functions. Cosine function goes like this. It's like 1, 0, negative 1, 0, 1. That's the cosine graph, right? So that's what we have to draw here. And then also include the amplitude that goes way up till 3, right? So way up till 3, negative 3. So starts at 3, 0, negative 3, 0, and then positive 3. So that part is done. And then finally, to get the answer, here's what we do. Here's 1, and this is like the center of the graph. And because I added everything by 1, so you add 1, so that's 4. Negative 3 plus 1, that's negative 2. Okay, here's 1. And then the graph has these 1, and then 1 here. Those 5 points. Pi over 12, 5 pi over 24, pi over 3, 11 pi over 24, and then 7 pi over 12. On this, we're going to draw the graph, which hits the 4. No, it's the 4 in the beginning, and then hits 0, but it's not 0, it's the midpoint, so it's 1, and then negative 2, and then hits 1 again, goes up again. So that's the graph. Now there are some other important things that you have to know along with drawing the graph. Amplitude is this number in front, as I said. Vertical shift is this number here, which is 1. The period would be the difference between these two numbers, right? These two numbers. So let's calculate that quickly. 7 pi, the end and the beginning of one full period gives you the period. That's 6 pi over 12, which is pi over 2 if you simplify. And then phase shift is the very first number you get. This is pi over 12. And that's about it. We figured out everything that's required from a graph. Now there's one more thing that people like to talk about and I didn't mention. So let me use a different color just to make a point. So in addition to this, there's something called the frequency, which is 1 over the period. So in other words, you take the reciprocal of the period, that's called the frequency. This is 2 over pi in that case. So not only you have to know how to draw the graph like this using the basic form of the graphs, but you have to also know the meaning of these numbers. Okay, so 3, 1, pi over 2, 2 over pi, pi over 12, these phase shift, frequency, period, vertical shift, amplitude, you have to be able to figure that out.